Good morning, everyone. Welcome to our Virtual Students and Early Career Scientists Conference 2020. And this is the last session, Section 8, Post-Session 6. I'm your chair, Jinghua Li, and I'm co-chair with Pickering. Say hello.
Hi, I'm Pickering. I'm a PhD student final year from University of Leeds, and I'm studying weather radar.
Thank you. I'm Jinghua. I'm from Castro University. I'm a researcher in the built environment and air quality. We have 6 speakers in our session. They're each going to have a 3-minute presentation, followed by a 2-minute Q&A. You can download their presentation from the handouts on the right-hand panel, which you can enlarge and make it more visible for yourself on the PC. Okay, our first presenter today is Paloma, Castro, PhD student from the University of Leeds. Paloma, when you're ready.
Thank you.
Thank you.
Hi, everyone. I'm Paloma Trascasa Castro. I'm a first-year PhD student at the University of Leeds. And today I'm going to talk about the linearity of the stratospheric and Euro-Atlantic sector response to the El Niño Southern Oscillation, or ENSO. In my poster, you can follow the order of the poster by the numbered sections, and also in this little plot on the right of the poster, you can see the order of the experiments that I'm going to talk about. Cool. So ENSO is the leading mode of interannual climate variability. And in this study, we investigated if the magnitude of the climate response to ENSO in the stratosphere and in the North Atlantic was dependent on the magnitude of the event. And to do so, we ran idealized experiments with the Hadgen-3 model, where 8 different magnitude sea surface temperature anomalies, or SSTs, were imposed in the equatorial Pacific. And you can see the imposed SST pattern in figure 1. So we have 4 El Niño events of increasing order of magnitude and 4 La Niña. And this was run for 54 years, and we have perpetual ENSO conditions. By changes in convection and upper level divergence, ENSO events trigger anomalous train of planetary Rossby waves that are shown in green in this schematic on your right. But as you can see in figure 2, the Rossby wave source anomalies are much stronger during El Niño than during La Niña. And this large asymmetry is going to be very important in the following steps, as you'll see. So moving now on to figure 3, in the North Pacific, El Niño deepens and shifts the allusion low eastward, while the equivalent magnitude La Niña perturbations drive anomalies that are opposite in sign, but approximately 4 times weaker. The allusion low acts as an atmospheric bridge, enhancing the vertical propagation of Rossby waves from the troposphere to the stratosphere. And in the stratosphere, El Niño perturbations weaken the stratospheric polar vortex at a rate of -3 meters per second per Kelvin. So the weakening of the polar vortex is linear to the magnitude of El Niño. And this, as you can see in figure 4, this leads to an increase in the frequency of southern stratospheric warmings of up to 62%. These results do not support a saturation of the stratospheric pathway for strong El Niños, as it was suggested in previous literature. Also, as you can see in figure 4 in the scatter plot, only the 2 strongest La Niña perturbation experiments strengthen the polar vortex, but there's no significant change in the frequency of southern warmings for La Niña. Back again in the troposphere in the North Atlantic sector, and looking now at figure 5, we find that the negative response of the North Atlantic Oscillation, or NAO, becomes stronger as the El Niño forcing increases up to 3 Kelvin. And that is predominantly associated with the downward influence from the stratospheric pathway. The negative NAO pattern involves wetter conditions over Southern Europe and colder winters in Northern Europe. Again, only the 2 strongest La Niña perturbation experiments can lead to a positive NAO index, but this is very weak. And this suggests that the mechanisms for the Euro-Atlantic response to La Niña might be different from the mechanisms for El Niño. Thanks for listening, and I'm happy to answer questions now or by email.
Thanks,
Cheers.
Paloma. We have a question coming through from Ben. Will you continue this work or start a new project? What is next for you?
So I'm doing a PhD now, and this was part of my master's study. So at the moment, I'm looking at how the global impacts of El Niño and La Niña change if you change the mean climate state. For example, if you change SSTs in the North Atlantic, or if you add global warming signals. So I'm still looking at ENSO, but now changing just the mean climate conditions. Thanks for your question, Ben. It's a very broad and interesting topic.
Thanks, Paloma, and thanks, Ben. Okay, I think we just about time to move to the next one.
Thank you.
Thanks, Paloma, again. Thank you. And we're going to have our next presenter. It's Amethyst Johnson, a student from University of Manchester. When you're ready.
Thank you.
Thank you.
So, yeah, this was my third year dissertation project at the University of Manchester. It was environmental science degree, so I kind of took it off course a little bit. But there was something interesting in the 1980s where the Soviets sent a few landers to Venus to kind of go through the atmosphere, which is very dense, and measure all these different properties. From that research, it was widely concluded that there were no aerosols below 30 kilometers. But recent analysis of the same data suggested that there was an anomalous electrification near the surface. So what I'm trying to do is test the hypothesis that this anomaly was caused by a layer of dust that was maybe uplifted from the surface or just pre-existing. So to do that, I took the analogy of Sahara Desert, where it's a very unstable atmosphere, a lot of mixing going on, which is the same as what we expect for the Venus surface as well. The dust analogy comes from being uplifted. It's the same kind of dust we expect from the Soviet photos. So the project was really, can a Saharan analogy estimate the charges on aerosols near the surface of Venus? And to be honest, the answer to that was no. So the calculations, the model was mainly modeling a spacecraft descending through a lower atmosphere with an unstable particles which were uniform in size and distribution throughout the layer. And we calculated the charge on each of the aerosols and see what the accumulated charge would be on the spacecraft to see if it aligned with the measurements. So my results found a charge of 3 orders of magnitude lower than what was actually measured. That comes from the space charge and the discharge current as well. In 2 different models that I tried with a completely unstable atmosphere and also a stable one with huge particle sizes, it just wasn't feasible that the charges on the charges that were measured could be attributed to aerosols. So we just had to offer some other possibilities, explanations, and also maybe that the Saharan analogy just wasn't good enough to replicate the environment of Venus. So I kind of rushed through that, so it might be a little bit muddled, but I'm happy to take any questions on that. Yeah.
Okay, we've got a question again from Ben. Can we use your results to inform future missions? And how will you get these results to people who use this mission?
Okay, so the project first came about because I spoke to a guy who works at NASA, and he's done a lot of work on Venus. So it directly feeds through to his research and directly informs their future missions. But to be honest, all I think with this is that more investigations need to be done, because plainly attributing it to aerosols isn't sufficient.
Okay, we just about have time to have a quick one. And from Ruth, do your results suggest that there are no asteroids present, or just there are other ways for asteroids to become charged?
So the possibility is that there are aerosols there that are charged, but we also need to consider the incredibly high pressures, which could have caused more collisions, higher charges, which I didn't really take into account during this study. But there could have also been other charging mechanisms, as shown on my figure here with the little yellow lightning bolts. So I think charged aerosols is just one factor.
Right. Thanks a lot. Thank you, Ahmed.
Thank you.
Thank you. Okay, we're gonna move on to the next presentation. It's from it's from one research intern and 2 students from Ahmedabad University. Hello, Dhyey. And could you introduce the other 2? I probably need to get myself away. And
hi everyone, my name is Dhyey, and I'm
right.
at
Take
College
it away.
of Engineering, Ahmedabad, India. Here I have Rudradutt and Mihir, who are my classmates and teammates. So our topic for the presentation is study of meteorological profile of Ahmedabad city and its relation to air pollution dispersion. So our main research question for the study was that how meteorological parameters affect air pollutant dispersion in the city. And our larger goal and ultimate goal was to develop the atmospheric carrying capacity for the city. So for this particular study, we divided our topic into 2 distinct studies. So first one was developing meteorological profile of Ahmedabad city, for which we analyzed 10 years of meteorological data, and we developed the understanding about temporal evolution of various parameters that affects air pollutant dispersion, such as surface heat flux, Morning-Nabucco length, convective velocity scale, potential temperature, mechanically generated boundary layer, and convective generated boundary layer. And then we carried out air pollution dispersion modeling by the use of air mode software. And then we try to understand that what are the relation to meteorological profiles and meteorological parameters with air pollution dispersion. So Mihir will now explain you the meteorological profile that we developed.
Hello everyone. So first 2 graphs, as you see in the below, is the Morning-Nabucco length and surface heat flux. So as you see in the graph, in the early morning and in the noon hour. Yeah, I'm here. Are you not getting my voice? Hello. Hello. Yeah. So first 2 graph is Morning-Nabucco length and surface heat flux. In the early morning and the noon hour, both value of Morning-Nabucco length is decreased and the surface heat flux is increased. So both are good for the atmospheric pollutant dispersion. And the uppermost part, as you can see, the 2 different graph of the convectively generated boundary layer and the mechanically generated boundary layer. For easily understandable, we will develop another graph is of comparison of both the layer. As you can see in the noon hour, the height of the CBL is increased and the height of the MBL is decreased. Third graph is the heat flux, as I described you earlier. And the another plot we develop is the WR plot for Ahmedabad city using WR plot. And the one thing we are observed throughout the time period of the this 2011 to 2019 is the major wind direction for the Ahmedabad city is from southwest to northeast, which is towards the city, and this is not the beneficial for Ahmedabad city. So after getting the meteorological profile of Ahmedabad city, we will link it to the relation of, we will link it to the air pollution of Ahmedabad city. So next will be carried out by Rudradutt.
Profile and then put it to the dispersion model that was air mode, and we basically create several plots for monthly variations and for pollutants SO2, NO2 and particulate matters, and we observed that for the same emission sources in different meteorological parameters, the ambient air quality standards were being breached. So that means that meteorological profile or meteorological parameters had some role to play for the breaching of this ambient air quality standards. We also observed that with horizontal dispersion for each pollutant and in same meteorology for the same day. So they were behaving very differently, as you can see in the poster also. So we tried to study that further, that how the horizontal dispersion is occurring with respect to the meteorological parameters. The future aspects of these studies are that you can generate QQ plots, which we had planned, but due to this COVID-19 situation, we are not able to do so. So by generating QQ plots, you can get a very clear idea. Also, the applications is that you can cite industries according to this carrying capacity that is being calculated, and industry-specific pollution reduction goals can also be applied for not breaching the ambient air quality standards for urban planning and various other specific applications also. So basically, we observed and we concluded that meteorology had very important role to play in this air pollution dispersion, along with the sources of generation. So thank you everyone, and we are open for the questions if you want to ask any.
Thank you.
Yeah.
Thank you, guys. Okay, we have a very quick one here. And from Ben, he's asking, does your group have connection with lawmakers, politicians in the region so that they can see information and help improve air quality in Ahmedabad?
So we have no direct connection with any politicians, but our university has got professors who are working in environmental clearance committee, and also where we are interns, the professors are basically in the IPCC third group, that is mitigation part. So we are presenting this study to them and are also further considering to cover whole city as a source, including not only just industries but also domestic and vehicular emissions also. So that could really help in policy making and develop new ambient standards or city-specific standards for this particular city.
Okay, thanks a lot.
Yeah.
Thank you. We will now move on to the next presentation. The next one we're gonna have is from Steph Holtzman, specialist in GIC and hazard mapping. It's from GBA Risk Management Limited.
Hi.
Hello.
Hi, everyone.
Hiya.
So yeah, I work as a GIS and flood hazard specialist at JBA Risk Management, having studied meteorology and oceanography at the University of East Anglia. So in this study, I investigated how the US insurance industry could be impacted by the use of comprehensive flood maps, like those that we've developed at JBA Risk Management, and specifically looking at a Hurricane Harvey case study. So the US flood insurance market is very different to what we know in the UK. Firstly, flood insurance must be bought separately to home insurance, and so there is a very low take-up of this kind of insurance across all states in America. The National Flood Insurance Programme, as known as the NFIP, currently dominates the US flood insurance market. This is managed by FEMA, the Federal Emergency Management Agency. It is there to offer primary flood insurance to properties FEMA consider at a significant risk. It also reduces flood risk through the adoption of floodplain management standards in the participating communities. Only properties in these communities have access to policies in this programme. So FEMA has classified areas into special flood hazard areas and non-special flood hazard areas based on their 100-year flood map. It's only properties within the special flood hazard areas and one to mortgage that it is mandatory for them to buy flood insurance. So when Hurricane Harvey hit the US in 2017, FEMA's flood maps underestimated the flood risk, and so less than 20% of homeowners had flood insurance. At JBA Risk Management, we've created river, surface water and coastal flood maps at a 5-metre resolution for 6 return periods, the 20, 50, 100, 200, 500 and 1500-year flood. We take time to prepare our input data and then use our in-house 2D hydraulic model, JFlow, to capture river and surface water flood, as well as horizontal projection modelling to capture the storm surge hazard. We then use iterative GIS techniques to process the hydraulic model outputs to create seamless flood depth layers for the 6 return periods. So I spatially analyse our 100-year and 1500-year return period flood maps and FEMA's 100-year flood map against the claims made in Hurricane Harvey and the high water marks which were recorded with the event. And I found that JBA's flood maps captured many more of the claims in Hurricane Harvey in the non-special flood hazard areas in both our river and surface water maps, and therefore the US insurance industry would definitely benefit from the newly developed high-resolution comprehensive flood maps, as they define flood risk, better define flood risk across the country. Thank you. Any questions?
Any questions here? Okay. I have a quick one here. And so the flood mapping you have, is it based on just the case studies or observations or measurements or modeling?
Sorry, say that again.
What and how did you make those flood maps? What's the data and
As the data is from FEMA, redacted claims data. It's open source now, so all the claims that have been made through FEMA are now available to the public.
Oh, that's brilliant.
Yeah.
Open source. Okay. And so this flood map is mainly based for the US. Are you looking at some other parts of the world, or just concentrate on the US?
Sorry, say that again. I can't really hear you very well.
Right, sorry. I mean, is it possible to make the application beyond the US market? You may look at different parts of the world.
Yeah, definitely. So as long as there's data to look at where the floods happened, then we can definitely use our maps to see, like, define risk. We've got maps globally, both.
Right. So you mean it's depend on the open
Yeah,
source?
it depends on.
So with the open source available, you can always plug them in the model and make it possible. No, that's brilliant.
Thank you.
Great job. Brilliant. Do we have any more questions? Okay, it's a quick one from Ben. Is the typical amount on this type of data?
No, I don't think so.
Okay. Okay, right. That's a quick answer. We've got time for the final question here from Hannah. Is the aim to make these maps available to public so they know that they should take out insurance, or more a tool for the insurance company?
Yeah, it's more a tool for the insurance companies.
Right.
Yeah, so they can then see the flood risk and decide where should be. Well, everywhere should definitely have flood insurance. Just that many in the US think that they don't need it currently.
Oh, okay. Right. So it's more for the benefit of insurance company. Right. So I have to. I'm running out. Sorry.
Thank you.
Thanks a lot. Very interesting talk. Thank you. I'm gonna give the floor to Ben now. Ben.
Thank you. Thank you very much.
The session. Thank you.
Thank you. Cheers. I just want to remind everyone that in the top right up here in the handout section, you can download all these posters. So the idea is that you get an overview from the speaker in these short talks, and you can download the ones that interest you, which of course will be all of them. And then you can read them at your leisure and get in touch with people. So we'll move on now to our next speaker, which is Isabel Smith. Hello, Isabel. If you want to turn your webcam on. Hello, good morning.
Hi.
So I'll pop up when you've got 1 minute remaining, and I'll let you introduce yourself. So the floor is yours.
Thank you. Hiya, I'm Isabel Smith. I'm a final year student on an integrated master's degree at the University of Reading, studying meteorology and climate. My poster here is my dissertation topic, where I looked at the meteorological influences on lightning strength in a changing climate. So basically, I wanted to investigate how the charge within a thunderstorm is going to change with climate change. And to do this, I decided I would try and find a relationship between the current values on individual lightning strikes and meteorological variables. And then after finding this relationship, I could use climate predictions of these meteorological variables to hypothesize the future current values on strikes and overall the charge within storm clouds. So using a lightning detection system called Linit and the ECMWF ER5 reanalysis data, I did a case study investigation. So I chose a storm system that lasted around 48 hours and had a high density of lightning strikes over the English Channel, as you can see from figure 1. On my poster, despite the fact that I considered many meteorological variables, I only talk about CAPE, convective variable potential energy, and surface convergence as they had the best correlation. So my first steps really were trying to understand the best way to compare these two physically very different quantities. So figures 3 and 4 basically highlight that you really need to take consideration, obviously, that there's a time lag between CAPE and surface convergence developing before you have lightning strikes. You need to consider that the storm is going to build. So my next approach was basically to grid up the case area into small subsections, and then from that, calculate the median and the 95th percentile current values for each grid square, and then work out for each hour that lightning occurred in it. And I did this for both positive and negative lightning strikes. The storm system had a good distribution of both polarities. And then I would compare these values to median and maximum CAPE and surface convergence values from that same hour that the lightning occurred in. I also considered CAPE and convergence values from the hour before that and 2 hours before that due to this time lag possibility. So my next figure that I'll point you towards is figure 5, which is my main plot. It basically shows the best relationships. So there were strong nonlinear relationships. This is proven through 2 statistical tests called the chi-square test and the odds ratio. So here we have a strong nonlinear relationship between the hour before CAPE with the 95th percentile positive current values. And we also have a even stronger nonlinear relationship between the same hour convergence values and the 95th percentile positive current values. So positive lightning strikes seem to have a better nonlinear relationship. Despite some uncertainty, CAPE and surface convergence are likely to increase and develop in future climate scenarios. So if we combine this with the non-linearity of these results, I can suggest a threshold hypothesis. So in the future, we are likely to meet a threshold value of CAPE and convergence. And as we meet this, we're going to have a greater range of lightning current values on individual strikes, so it'll reach a higher tailing end off point. And yes, that's the end of my presentation. Of course, the electrical process is very complex, and if I had more time, I wish I would have done more. But thank you. Do you have any questions?
Great, thank you very much. We do have a couple of questions, so I'll put them up on the screen now. Hi, Isabel. Thanks for the great presentation. Do you think you'd get similar results in areas of deep convection and high frequency of thunderstorms, such as in the tropics?
Hopefully. I mean, I wish I could repeat these again with more case studies, because I'm just looking at a small storm system over the English Channel. It'd be fantastic to look at a big tropical storm, just so you get the data for it.
Mm-hmm. Cool. And Amethyst has a similar question to what I had written down. Is the lightning data freely available? Is it open source?
I got it from my supervisors, and they got it from a different project that they did, so I don't think so. It's from, if you apply for it, I think you can pay for it. I think Linit is its own private organization, but they're very good because you get polarity, which you don't get with the Met Office or a lot of other ATD networks.
Cool. And then I just had a final short question. You talked about how this could be used to guide forecasts in the future, but do you have connections and channels? I've been asking everyone this, but do you have a way to actually get that information to the people who need it?
Currently, no, because no, I don't. But I went to a conference in November, and I was talking to a Met Office employee who's doing a lot of research into this anyway, because the North Sea has terrible positive lightning strikes that are really affecting helicopters and stuff. So I think there's a lot of other research going on that hopefully has more outsource and more reach than I do.
Great, that's really exciting. Look forward to hearing about that in the future. All right, thank you very much. We'll move on to our final speaker of this session, Joanna Raymond, if you want to turn your webcam on.
Just wait for it.
All right, I'll give you a warning when you've got 1 minute left, and if you want to introduce yourself, the floor is yours.
Okay, so hi everyone, I'm Joanna Raymond, a PhD student at the University of East Anglia. and I'll be presenting part of my PhD project looking at the impact of weather and climate variability on winter wheat in the UK. So despite innovation in farming practices, the agriculture industry is still witnessing strong impacts created by interannual weather variability. Interannual variation in wheat yield can be seen quite clearly in the UK annual wheat yield anomaly plot at the top of the poster. This can have significant implications on the entire food supply chain, from things like fluctuations in farmer income to prices of bread and flour for the consumer. To analyse this interannual variability in more detail, we use variety trials data. So every year, plant breeders submit their winter wheat varieties for testing, and those that make what is known as the recommended list are then grown in different locations around the UK. Winter wheat trial locations for the last 30 years can be seen in the map colour-coded by the year in which they were used. Each site location is subject to a different environment with climatic differences. Therefore, we can use this data to look at the interaction between varieties and the environment. So our objective is to identify more resilient winter wheat varieties and isolate the weather impacts. So to go with this variety trials data, we've been exploring the best gridded data set to use. Although the UK has good coverage of weather stations, they're still irregularly distributed, and they can have periods of incomplete data. So we analysed the performance of gridded data sets by validating them against station observations, and these validation stations can be seen on the map. These data sets can also be seen in the centre of the poster and include observation-sourced, reanalysis and satellite data sets. We're using the best performing data set to carry out regression analysis between multiple climate variables and winter wheat yield. So an example site is Limavady in Northern Ireland, and the yield plot shown shows treated yield in blue and untreated in orange for this site. So treated seeds are those that have been treated to protect them from pathogens. For example, a fungicide can be added. In the particular time series shown, we can see a peak in untreated yield in 2000 and a trough in 1998. So this coincides with the driest and wettest July in this period, which can be seen in the rainfall box plot in the bottom right. So we'll therefore be investigating this potential relationship further using statistical analysis. And the results of this work can inform plant breeders on novel breeding traits and farmers on what variety traits might be best suited to their specific environment. So yeah, that's all. Thank you. If you have any questions, please just put them in the chat.
Thank you very much, Joanna. Yeah, if anyone has any questions, feel free to type them in. I've got a couple just to start us off. Have you considered using any crowdsourced data? You talked about the lack of stations available. We had a good talk from Jonathan Kearney yesterday morning about using crowdsourced data sets, and I wonder if you considered using.
Yeah, so we haven't.
Like
I think because there are so many gridded data sets available, and from the validation we've done, I mean, the sort of the accuracy and the correlation with the station data is so high, particularly for HAD UK and CH Gear, which they have a resolution of 1 kilometre, so they're very good. But it's definitely something to look at, especially if there's particular areas, perhaps nearer the coast, there is some relationship between distance from the coastline and the performance of these data sets. So it could be, something to look at for perhaps the weaker areas of the data sets.
Great, thank you. We do have one question. Have you tried obtaining Environmental Agency, Scottish Environmental Protection Agency, or NRW rain gauge data?
No, again, we haven't actually used any of that. So yeah, that I should definitely look at that. I'm not sure sort of what the distribution of the rain gauges are for any of that. So yeah, thank you.
Great. And then I just have one final obligatory question about have you got channels to distribute this data and these results through to make sure it gets to the right people?
Yeah, I mean, so this is additional funding from the British Society of Plant Breeders. So they're heavily involved in this project. They're helping provide us with the variety trials data, which is highly confidential. So yeah, it goes through them. We've got contacts with several farmers and publications that are aimed at farmers. So yeah, I think there's many channels to distribute the information.
All right, sounds good. Well, if we don't have any more questions, I think we can wrap things up there. Or we do have one quick one. How much do you
Don't send
trust
that
the
to me, send that to Roberto. I mean, I guess observations are always limited in how much you can trust them. I don't know exactly for rain gauges, but that'd be something to look at if you're using them. Definitely be aware of that.
All right then. Well, yeah, let's wrap things up there. We now have quite a significant lunch break of around 2 hours. That's due to just some reshuffling of presenters. So yeah, you've got plenty of time to get up, have a break, have something to eat, and feel refreshed, ready for our next session, which is at 2 p.m. and that's our final session of the conference. The keynote session on science communications, chaired by Hannah Brown and Sean Dempsey. We have some really interesting speakers there. So I hope you can join us all then. And thank you everyone for joining, and to all of our presenters.